Hey guys, Thomas here, and today we'll be talking about this. This is the BMS Racing JS-1. This is our first production-ready race frame to actually launch onto the market. So today we'll be telling you all about it, sort of why we've done this the way it is, and also covering more specifically the build of this. So how I build it, some of my sort of build tips for this, how it's intended to be assembled. That way when you go to do your builds too, they can come out nice and neat and race ready. Without further ado, let's get straight into it. Okay, so the first thing we'll be doing is grabbing our bottom plate here, and we've got our first little set of parts. So these are all the bits to build sort of the bottom structure of the frame. Okay, so we've got our bottom plate here, or mid plate. We've got our press nuts, we've got our washers, we've got the little screw that we use for actually the for the press nuts. We've got the outer arm bolts and the center stack bolts. Okay, so the first step to building this frame is we're going to get all the press nuts in. So there will be press nuts on all the outer corners of the quad, and then what you've got to do is decide if you're using the 30x30 or 20x20. So if you're using 30x30, you want to use these bolts here for the these holes for your press nuts, and if you're using 20x20, you want to use the inner ones. So if you use 20x20 also, the arms will actually lock in a little bit nicer, just because I've got a bit more room to seat up better, but 30x30 works fine anyway, and that's what I'll be using on my primary race fleet. Okay, so we've got the outer 4 press nuts in. Now for the inner 4, for 30x30, which is what I'll be running for this build, you'll want to use these holes here, but if you're on 20x20, you're actually going to want to move all your press nuts down into the 20x20 slot. Like so. Okay, so we have all of our press nuts in. Now the next step we're going to do is make sure the roll cage fits. Sometimes with the tolerances of the carbon, it can be a little bit tight. So we've purposely left it tight, that way it can be filed back, because you can always take away material, but you can never add material back. So you just basically make sure that this can actually slide on. So you can see this one here, the roll cage is actually a little bit tight. Okay, so what you want to do is file away at the bottom part of these tabs. What that'll do is just open up that gap just a little bit more for the actual roll cage to slide in properly. That's where we want to actually take the material from, not anywhere else. And then usually I do that under running water, that way the carbon dust doesn't actually float up into the air. So I filed away these, I just took my time, just made sure that the filing was nice and flat, and now these both slide in. So as you can see here, just a quick test from the outside, slides in. You want it a little bit tight, so like at the right angle it slides in right, but if you get it a little bit off, then it won't go in. And then you can even check the inside ones here, make sure the inside ones actually fit, which they do. So now we can just make sure these actually do slide in on their sides properly, and if they do, we'll continue with the build. With a lot of my builds, I like to actually dry fit the parts before I fully assemble everything, just to make sure everything does go together properly. It's just something that, well, with this frame, you have to do it for this purpose. I do it with every frame I build anyway, just because it helps to make sure the frame goes together right before you actually start putting parts in. Okay, so there you go, the roll cage fits on perfectly. It slides on properly, but it does have a little bit of a click to it because it is still a little bit tight. It's sort of how you want it. You don't want it to see actually really putting pressure on the carbon to get it in. You don't want a lot of tension, you want it just so it butts up nice and smooth. So this will all depend on the batch of carbon and sort of with the thicknesses, but by actually having it so you can just file away at it, it means you're guaranteed to get it perfect every single time. Okay, so what I'm going to do now is pop off the two sides of the roll cage off, and we're going to continue with the actual build itself. So these pop out real nice and easy, just a little bit of pressure up here, and you see one's already slid out. Next one, just a little bit of pressure, not much at all, should be necessary to pop these off. So that's one, and then second one, nice and easy. So what we'll do now is actually get our arms on. So keep in mind with this, the arms are, there's one offset bolt here, because this is a squish frame. So you need to make sure sort of the one that sort of pokes out in the middle, that's always pointing front and back of the quad, not left and right. So what we'll do is get one of our M3x12s, and I'm actually need to change drill bits here. So going from, or hex bits, so going from 2.5 to 2, and we'll use 2 for the rest of the build now. Okay, good, so we're ready on 2. We're going to, actually start with the bottom plate, I did that wrong. Okay, so we're going to slide our M3x12 into the bottom plate, then we're sliding the arm next, and then from there we're going to put the actual mid plate, I guess it is, on, mid top plate. And you just want to loose fit this, so sort of tighten up to the point where there's a little bit of slop. So there you go, so there is still movement there, but then that way it's nice and easy to get the rest of the arms in, so we'll get the next arm in now, like so. And we'll get the rest of the bolt in. Okay, so we've got the outer bolt in, now we're going to put our center stack bolt in. So since I'm using 30x30, I have the press nuts in the 30x30 section. And we're just going to start screwing in these bolts. These take a little bit longer because there is that press nut you have to get through, but the reason why we've done that is so that you've got a nice mounting point for your flight controller, and that way if you have dampening on board, like so the Flight 1 boards or the Foxia boards, then you're going to get the best possible dampening and the best possible data for your flight controller to work with. Okay, so we have all the bolts in. They're all a little bit loose right now. So if you're on 30x30, you have a little bit more slop than a 20x20. So what you're going to want to do is make sure you're holding compression on one side. So I like to hold compression to make it a little bit more squish. And then you're going to actually go and tighten up all the bolts. That way you have a nice even geometry that your quad is. So I'm going to start with the outer bolts. And then work my way onto the inner bolts. And make sure everything's tensioned up nice and evenly, and also the frame is nice and symmetrical. Okay, there we go. So at this point, if I was building a fleet, I would probably just keep going and start putting ESC equipment and stuff on. What we're going to do though, however, for this is actually dry fit everything once more, make sure the whole frame's together. That way also I can talk a bit more about how this frame is designed to be assembled. So we'll pop these washers in straight away just because that's an easy step I can do. For the F55 amp you want to use these, but depending on your ESC or your flight controller, you might need to change these to something else depending on how much space you need between your ESC and flight controller, or ESC and carbon. Okay, so now we'll get the roll cage fitted without any equipment on it. So what we're going to do is start with this little piece here. We're going to just grab one of the standoffs and slide it into the center section. So it's a pretty snug fit, but this is something you should never really need to access again once you've done this once. So just get it nice and tight. Okay, so we have the standoff in nice and flush, and this will make sort of your center bracket for mounting your receiver and video transmitter. But let's get straight onto the roll cage. So we're going to clip the two roll cage pieces on. Make sure these are lined up before you press them in, and they should slide right in, no dramas at all. And the second piece. Once again, make sure it's lined up. If it's not lined up, it won't want to go in, but once it is lined up, it should slide straight in, no issues. And from there, we'll get these standoffs in. I usually just sort of rough fit it, and then you're going to take your M3x6, there's 4 of these in the kit, and you're going to want to use that to secure the front and back standoffs. The center standoffs are held down by an M3x8, 2mm 3x8, so there's a little bit more like that. For now, I'm just having everything a little bit tensioned here. With this, because we're going to be going on to the full build after this, I'm not going to fully tighten everything. There isn't really much point, so we're doing this more to make sure that everything fits properly before we get onto the full assembly. Okay, so here is the bare frame of the JS-1 assembled. So next to a fully built one. So this will be part of the actual main fleet. So the only difference really between this guy and this one here is that we're going to actually be running the 2000 kV BMS motors. So the Goldlines instead of the Redlines. I've already got 3 of these guys. So this will actually be a part of the main fleet that will be racing pretty much everywhere for 2019. So it should be exciting. Anyway, let's talk about some of the features of this quad. So let's talk about how the build's meant to go together. For this, we'll use the bare frame as it is, and we'll also use a fully built JS-1, since the internals will be exactly the same on these and how I go about building it. So first, I'll show you actually how to take off the pod. What you want to do is you're going to flip it over, and you sort of put your 2 fingers in here, and you just sort of pull on this, and that pops off nice and easy. Then when you slide to the back, you'll hear it all click when you pull the back section off. And then now all you need to do is lift up, and the pod comes off. So now we have the internals fully exposed, so you can actually see sort of what's going on here. So front side here, you've got the camera mount, just pretty generic camera mount. That way you can sort of have a full range of tilt. You can really get the tilt right to exactly what you want. As far as the electronics mounting, you have your flight controller ESC in the center stack. There's more than enough room there to fit in like a Flight 1 board or most of your Betaflight really high power ESCs. In this one, I'm using the F55 amp ESC with a Foxia F722 flight controller. Looking further towards backside, you can see here you've got your video transmitter. I'm using the TBS Unify Pro 32, but the Unify Pro Nano also works perfectly. And then we've also got the Crossfire Nano up here under the antenna mount. So if we remove the 2 bolts on the antenna here, this whole sort of SMA section lifts off, and you have full access to your video transmitter and your receiver. Then you pop that little compartment out and you undo your 3 bolts over here, and all of a sudden the full roll cage comes off and you have full access from the flight controller down to the ESC level. Okay, so we have 2 module bays up top here, and these are primarily used for your video transmitter and your receiver. You could use the other 2 module bays, but these ones are more protected and it's really more built around using these. You've also got 2 little wire channels for your wire routing to go through, as you can see here on the full frame. And then you've also got 2 more module bays underside. So this module bay I mainly use for my receiving antenna. It's just a really convenient spot to put it where it's really out of the way, and it also gets the antennas nice and far away from your motors and from your ESCs and everything that could possibly be screaming at it. The other one here up front, I normally just leave this free for normal racing, but for certain scenarios like say Shenzhen where you need to run a camera and a LED controller, that's where I can actually fit this up front. The tiny LEDs ones work really well, and you can just fit a Maytech LED controller if you want to, but if you want to try and get a bit more weight, then the tiny LEDs one is the way to go. So we've also got the capacitor up front here. Now, if your capacitor is too big to actually fit up front, then you can just run it at the side like a normal quad. There won't be any disadvantage there. But if you want to get a little bit extra and capacitor is small enough like it is in the F55 amp, then you can actually tuck it in here. It'll be nice and protected, and you'll also have additional weight saving. So what we provide is a little 3D printed cap here, and that goes on top of the capacitor. You can just tape it on, and then once you've done that, it won't actually short out on the carbon, and that way you can actually fit it up front there nice and safe and get that sweet, sweet air. So what I'll do is now I'll pull the roll cage off back down to the sort of ESC level, even though we don't have any equipment on this yet. That way you'll actually get an idea of how I go about disassembling it, sort of the methodology I use. It's just sort of a really nice method to follow. That way the build stays nice and neat when you're working on it and whenever you have to do sort of your scheduled maintenance. So let's move this out of the way, or unplanned maintenance. That happens sometimes in racing. So we've got the frame here as it is. Usually the first thing I take off is the antenna cap. It all depends on really what you're working on, but it's basically 2 bolts up front, so these come out really easy. You can sometimes just unscrew these to a point. It just really depends on what you're doing, so I'll just partially unscrew them because we don't really need to take the bolts right out. And it's just easier to have them sort of in the TPU. The TPU does hold onto the bolts a little bit, which is kind of handy, so you don't lose bolts whether you're working on the quad. And then this piece would slide off, like so. And then now we've got access to, if we had a video transmitter receiver on here, we've got access to this panel here. So I usually keep the wire lengths a little bit long. I'll show you more about that later. But that means that this section can actually pull out if you need to do any work on here. For now we don't have anything on this, so we can just set this aside. And now we'll take the roll cage out. It's just 2 bolts on one side I take. I usually leave the standoffs in on the other side just because it's easier once they're already on there. There's no real reason to take them off. So it's just the 2 M3x6s. And now we can just pop the roll cage off. So all you do, once again, just a little bit of pressure, and it should slide straight off. There you go. And then sometimes I'd leave this other piece on. It depends really what I'm working on. In this case, because we're doing the full build and there's no really reason to have it on there, so we'll just pop this off. And now we're down to the bare frame. What we'll do now is get some motors on here. I am just going to use 2 of the holes for the motors. You can have all 4 if you want sort of more security. It just depends on your build style. I like to leave the other 2 free, that way in case I do break a motor sometimes or like strip the threads, I still have 2 more bolt holes that I can use. For this build, we will be using the BMS Racing Goldline motors. So this one will make the 3rd 6L quad in my fleet and the final quad in my main fleet. So yeah, this is what we're going to be throwing onto this quad. It's going to be really exciting. These are currently my go-to motor for 6L racing. And pretty much what we're going to do is just sort of tape the wires in place so they sort of hold their position. So I usually put the tape, so just before the press nut, sort of around about here to about here, the tape actually spans. You can use cable ties or whatever you want. It's just tape's really, really lightweight and really, really neat. I specifically use 3M tape. It's impressive how hard it is to find tape that actually sticks to things, and the 3M tape's really lightweight and it does actually like stick. So yeah, if you need a recommendation for electrical tape, 3M's the way to go. I'm not going to use much here. The arms are really thin, so you only need about that much max. You can have a bit more if you want, but it doesn't really help with anything. So I'm just going to cut that. You want to try and get as little of your oil on these as possible too, because they will lose their stickiness. And you're just going to sort of line it up. Flip it. I like to start from about halfway of the arm, sort of a couple weaves across, and then just wrap it around nice and tight. and there we go. We've got the tape on. And you just want to do that for all 4 arms, and you're good to go. Okay, so we have the motors on board now, and now we're going to put the ESC on. I already got the grommets in. One thing to note with the T-mode ones, they are a little on the fragile side, so just treat them with care when you're trying to get them into position. But once they're on, just line it up and slide it straight through. Right now I like to run the XT60 on the side. It's just the most versatile way to run it right now, where you can run like 99% of batteries out there. And it's just a really versatile setup. This frame is designed to be very versatile. The idea being you can take it to multi-GP, FAI, or whatever else someone might throw at you. So we are trying to go for a little bit of versatility here. Now what we're going to do is actually get the motor wires on. This is one of those things you can sort of do to your preference, and it's also dependent on the ESC you're running, sort of where the pads are. What I like to do is grab the sort of outermost one and route that to the first position, then get the middle one, run it to the middle position, and get the inside one and run it to the very inside position. And I sort of have it so they sort of keep staying on the sides like so. My dad actually likes to run it sort of more clumped up like that, still running those to the same position. It's just really a different style depending on sort of what you want. I think realistically Dad's is probably actually the better way to do it, but all my builds are all done the same way, so I may as well just finish this one the same way as the others. Maybe later on I'll actually switch that. Okay, so here's where we're at with the build so far. We've got all the motors soldered on. Now, if you wanted to, you could put the XT60 on now, and this will be dependent on the ESC you're running and also sort of the order you like to build. In my case, I usually leave the XT60 to the end just because of this actually sticking out, so I can just sort of leave it to the very end. But like I said, this really does depend on your build style and what components you're actually using. What we're going to actually do now is put the flight controller on, but before that I'm going to get the wiring loom ready for the ESC to the flight controller. So we've got the cable right here. Now I already know the pinouts for this, but depending on your ESC you want to look at the pinouts. Also, if you're looking at different batch numbers, make sure the pinouts haven't changed. Some companies have actually changed their pinouts before mid-batch, so just be aware of that first. And all I do is, because I don't need half these cables, I'm just going to take some of these out. So you want to really carefully just peel these little tabs back for the ones you don't want anymore. So I'll be using the Foxia F722 Dual. This FC has 2 different gyros on it, so you can use a 32K gyro or an 8K gyro. For now I'm actually using the 8K, but having that other gyro there means that as we continue with new developments and as we get to do more experimenting, we have that gyro there for more data. That way we can just sort of keep playing around with it and sort of run both of those to their maximum and see which one ends up being better off. So that's the flight controller here. I actually run it backwards on the quad, which I'll show you in a second, but there's actually pinouts right here that you can use. That's what I'll be soldering to, but there is also a connector. The only thing is I don't actually supply the other side of the connector, so you'll need to get that yourself if you want the ability just to have it connected to plug in and unplug. Otherwise, if you're going to just do it like me, then I'll just solder using these bottom pins over here. It'll sit like so on the quad, so this is the front. It's actually pointing backwards. Through Betaflight we can just tell it it's backwards anyway. And then when I'm soldering, what I do is I lift this up, I know the pins are back here, and I'll actually push it about here when I'm soldering. The reason why I do that is so when we actually route these wires through, there's a little bit of length there, so that whenever I need to service this, if I ever need to lift this off, rather than having just to always unplug the connector, I can just sort of lift this whole mechanism back. That way it's really easy to work on and easy to problem solve if something should happen to this clip. Pretty much all that's left to go on is your receiver, your video transmitter, and your camera. So what we'll be using is the Crossfire Nano RX for our receiver with an immortal antenna. Then we'll be using a TBS Unify Pro 32. Now for most racing I actually really recommend the Unify Pro Nano. The big difference between this and the Nano is the Nano only does up to 50 milliwatts. The main reason I get this one is because for some international races you need to go up to 200 milliwatts, and also if I go on a long range then I have the ability to go up to 400 milliwatts and use this as a long range rig. So it's really dependent on what you want to do. This is the more versatile option, but if you're purely about racing and your racing's all 25 milliwatt, the Unify Pro Nano is a really solid option and the video quality isn't any different. One thing you'll also need if you're using those is an SMA, a UFL to SMA adapter. You can get away without this if you want and just use a UFL antenna. The reason why I like this though is because it means that you can do pretty much every style of racing. If you're at multi-GP and you need to use a left-hand and right-hand antenna, this means instead of having, say, left-hand quads and right-hand quads, you can just have one set of quads and just have left-hand, right-hand antennas. It just makes it a lot easier, and it means too, the rigs you're flying, you can get a lot more flight time on them and get a lot more comfortable with them. Okay, now this step is probably the bit that takes the most planning, and it is pretty much the placement of your video transmitter and receiver. So on my quads, I like to run the video transmitter at the bottom and the receiver in sort of the midsection, and that will basically determine the wire that goes from your receiver to your transmitter. This is like your smart audio cable. So on my quads, because I've got the video transmitter sort of pointing backwards and the receiver also pointing back, the actual smart audio cable coils around up to the receiver. So you just want to keep in mind when you're cutting these wires to length that you want a bit of extra there to actually get it lined up. and also because you've got the heat shrink that's going to clamp down on it. So make sure there's a bit of extra length on your smart audio cable. It's just going to make the build a lot neater, and it's only one cable, so even if you run it at max length, it's going to add, what, maybe half a gram. So just play it safe on that one. Sort of pre-plan it on the table before you put it, but you'll see that now anyway. Okay, so now that we've got the video transmitter and the receiver ready to go, we've also got the camera ready. We're pretty much going to get all the wire lengths right. Now, for this wire here, for the smart audio cable, I've gone for about a 7 centimeter gap. 7 meters would be really big, wouldn't it? But anyway, So yeah, we've got a 7cm gap there, and these wires now we're going to trim to length. What we'll do is we'll get the actual length of these after that I'm using, but every quad I've done, I've actually built this method where I've sort of dry assembled everything to make sure the wire lengths will 100% work. It's sort of an extra step that I've added that I guess you don't necessarily need, but it means you're guaranteed to actually get the build right, and I'd rather take that bit of extra time to make sure the build ends up proper than end up taking a shortcut somewhere and making a mistake. So now we're up to probably the bit that's the hardest initially, but the payoff is absolutely massive with this design. So we're going to get our receiver and video transmitter on this bracket and nice and neat. I'm going to be taking advantage of both of these channels in this build. I just find it really makes the build nice and clean and makes it really easy to work on, and it also keeps the wires off the flight controller, which is really good for reducing anything that can put vibrations into your flight controller. Pretty much what we're going to do is we're going to start by sliding in these cable ties. I use all three. You can get away with just two, it really depends on how you want to build it, but I like to use all three, and I usually have them all on the one side. I just find it keeps it nice and simple. And then we're going to thread these around through to the other side straight away, like so. I'll get these distances right in a sec, but this for now you can just get them in approximate place and it'll be fine. And then what I'm going to do is get some double-sided tape. Okay, this is a double-sided tape I'm using. This is actually from Daiso, the like convenience store. It's just really good because it's really lightweight. It's got a bit of foam cushioning, which means your gear will last longer in crashes. It's just really, really good. The stickiness isn't actually the best, but it's enough to get things sort of tacked on. That way you can use cable ties and stuff later. But the little bit of foam dampening is really, really nice. So normally when I do this build, I start by putting on the video transmitter. So I'm just going to pop a double-sided tape. I'll actually put double-sided tape on both so they're ready. There's actually another plastic layer there, that way it doesn't lose its stickiness straight away. Like so. So this is all where sort of the planning really comes in. But we'll get the video transmitter on now. So we've got our sort of module bays here. And we're basically going to stick the video transmitter on like so. We're going to coil the whole thing around so the receiver sits here, and I'll just sort of show you how this goes together. Once you see it, it really makes sense. Okay, so we're going to stick this on here. Okay, that's stuck on like so, nice and easy. I'm going to keep these cable ties open for now because I'm going to use them to actually create some stream relief for the other wires. That'll make sense later, but for now we'll pull the wires we're not working on right now away. These will come back to later, they'll be outside of the cable ties. This one we're going to keep inside, just because we don't really need to access this one again. So coil it around, sort of like so. You can actually tuck it underneath the video transmitter, sort of beside the tape, and rotate this around. And as you can see, that'll sort of fall into place. Now what I like to do is actually push this back so the cable tie sits right on top of the UFL. What that means is it's pretty much guaranteed that that UFL is never going to pop off, meaning that if in a crash, if that UFL would normally pop off, now it's not. It's going to mean you can keep raising. It's going to mean you can have less link issues. It's just basically another point of redundancy. So what we're going to do is get this tape off. And I'm going to just focus on getting this on properly, but I'll show you this properly in a second. Let's get all this lined up. Okay, there we go. So, as you can see, this is actually directly in line with the cable tie. And we're going to actually use this cable tie over the SMA to stop the SMA one from wanting to pop off, and then this one we're going to go under, that way we've got a bit more movement for when we want serviceability. This is going to go straight over the receiving antennas wire 2, just once again another point of redundancy just to stop that wire from wanting to pop out, and we'll do that now. Okay, so now we have this bracket pretty much ready to install on the quad. What we're going to do now, I'll show you how the routing is going to work before we actually put it on. But these wires are going to route on the side here and into that channel. And then this other set of wires are going to route through the second channel straight over to the FC. Okay, here's our next big dry fitting of the assembly. So first we're going to get the roll cage on. Make sure it's going on the right direction, so camera's going to be up this side, this will be the back of the quad. Then we'll get the second half of the roll cage on, just clip it straight on, like so. Okay, we're just going to screw this in, just lightly, it doesn't need to be full tension right now. Just so it's holding it, it's not going to pop off. Okay, now that that's in, we're going to slide on the bracket. This will slide straight through. And that clicks into place. Then what we're going to do is we're actually going to use these screws just to hold it in, so that way we can get the wire routing right without worrying about this floating about. It doesn't need to go in all the way, just enough so it's actually holding. The tension from the rest of the roll cage will actually keep it in place. And then let's get the camera in. So I'm just going to pull these cables out of the way, nice and easy. This, I'm just going to slide up like so. And let's get this screwed in. Okay, this is where it gets a little bit fun. Now we've got to get the wire routing right. So, what I'm going to do is I'm going to leave these camera wires till last. Okay, so what I'm going to do is I'm going to start with the video transmitter wires. I just find it's sort of the easiest point to start with this. It all depends sort of how you assemble it and how you want it to disassemble. But pretty much all I'm going to do is route these straight into the little channel. And this is all just focusing on getting that wire routing right, trying to make it nice and easy for us to work on. Once you do this, sometimes it's handy just to have some pliers, that way you can get the wires out nice and easy and just pull them through. And so I like to actually tuck these wires under the actual cable tie, but I'll do that later. I'll right now use that just to leave a bit of slack there. And what we're going to do is throw this to the other side where the actual ports are for the video transmitter. Okay, so we're going to be using these 3 pins here for the video transmitter. So all I'm going to do is line the wires up over it. And even though I've got a bit of slack up the top, I'm actually still going to go a few mils past the board just to make sure I've really got enough extra wire there. Just for a bit of extra movement and a bit of extra serviceability. I've left about 3 millimeters extra there. And as you can see, those wires are now cut to size. What we'll do now is the same thing for the receiving wires, but this time going through the left-hand channel. I really like to keep these on separate channels, it just keeps the build really neat. It all depends on sort of what you're doing though and how you intend to use this frame. You can really sort of build this into what you want it to be. So sometimes it's easier to also route these wires through individually. Okay, so I've got the wires, they just tug away. Now all I'm going to do is push these across. We're using the very end pins on these, but I'm just going to go sort of approximate for now. Once again, I'm leaving a bit of extra slack, so don't have to be too critical here. And I'm going to leave about an extra centimeter on this one of wire, just to make sure I've got clearance. And that's those trimmed. We're going to do the same for the camera wires now, and that's just going to go straight to the back. So all I'm going to do is pull it beside the flight controller and then just snip them right at the edge. Okay, so we've got the wires routed now, so they're in the channel. One thing to keep in mind, you want a little bit of slack just for general serviceability, but also for your camera adjustment. So what I like to do is actually push the camera to full tilt and then push it full down. That way I've got a bit of extra slack already pulled in, and then I'm going to cut it just a tiny bit past the flight controller, and that should give me more than enough to play with. If you want to actually twirl the wires, you want to leave a little bit more wire just in case, because once you actually spin the wires so they're all in one little spool, they'll actually compress a little bit. But that is all the wires cut. Now what we're going to do is we're going to take off the roll cage again, and then we'll get this all soldered up. Okay, so we have all the wiring done. Pretty much what I've done is I've made sure the BECs on the flight controller are set to 5 volts for both the receiver and video transmitter. We've also soldered the video transmitter, camera, receiver, all that's done now. And we've got it to the wire routing. Basically the channel for the right side is used for the video transmitter, and then the channel on the left side is for your receiver. You can really set this up however you want, it just depends on your build. I've also got the camera going through the left channel. It's really all just relative to what parts you're using and how you plan for this to disassemble and reassemble. This is just the method I've used, and it is designed to sort of be like you can just use this channels for wire routing however you want. What we can do now is actually start putting this back together now, and pretty much at this point with my build style, we're not going to really pull it apart again unless like we smash it and destroy it. So let's get it all together. Pretty much what we're going to do first is get this wire pushed, the video transmitter wire pushed into this channel. I like it under the actual cable tie head, and then push into the right hand channel. I just sort of put a bit of pressure to hold it there, and then I'm going to move the camera out of the way, and we're going to plug this straight in. And now that's secured. Then what we're going to do is make sure all these wires are pushed in. I'll focus on the proper wire routing later, but for now we just want them sort of in the channel, like so. And then we're going to grab the second half of the roll cage and slide that in place. So just make sure it's lined up, take your time. And make sure it's not crimping any wires, so there should be a fair bit of slop there. It should be pretty comfortable, like, it shouldn't be tight. Now what we're going to do is screw on the bolts for the roll cage, front and back. I actually have the quad raised for this, so I'm trying to make it as good for camera as possible, but okay, what I'm going to do now is just make sure these wires are pushed in to the channel. I can actually use my pliers right now from the front side to push these wires forward a bit. And that'll give me a bit more length inside too to play with. So now I'm just going to coil up this wire a little bit for the camera. I did end up leaving a little bit extra length for that. And this just goes straight over the top and tucks in. And we'll use the bolts now to secure that on. Okay, here's a fun bit now. What we do is we're going to have the SMA, this all depends once again on where your SMA is, but I'm going to have mine rotate over like that. So we're going to actually slide in the SMA into the 3D printed SMA holder. And there you go, it sort of clicks in place. And once it's in, that's sort of it. You almost want to have the wire so it starts on the left side and curls over to the right side, that way it's as flat as possible. You'll sort of feel the weight's tensioning as you sort of bend it around anyway. Make sure the wires aren't on the carbon when you push down. I usually actually start on the side where the wires tend to pull up, where the most wires are. And I'm just going to look at it visually myself. And yep, nothing's touching, and I'm going to actually screw that in now. I basically just nip up that bolt till I just sort of start feeling it rub against the TPU and go a touch further. I don't like to really over tighten that one, just so the TPU doesn't stretch. I do occasionally check these bolts, usually maybe once every, 50 to 80 flights. I'll just pop open the canopies and go through them. The ones especially that aren't thread locked, they tend to loosen up sometimes. I haven't had one loosen up yet, but also if you've got, say, a bad thread lock or something, you never know. So I just usually check my bolts occasionally anyway. And my motors are always thread locked, so they should never come off, but I still check just in case. And then you just want to get the right side on. Once again, just sort of so it nips up. You don't need that much pressure there. And I can just sort of feel touch the TPU, just going to go a touch extra. And that is it, that's solid. And there you go, that's pretty much the bulk of the frame assembled. With this antenna, I like to curl it and sort of push the bulk of the wire into the bottom plate. And this will sort of sit like so. And then I just use cable tie on both arms, that holds it in nicely. Then the next bit we're going to do is the capacitor and XT60. So now we're going to get the XT60 capacitor done. XT60 is pretty self-explanatory. You just sort of cut it to whatever length you want based on your batteries. This I'm probably going to actually cut it a bit shorter than I normally do just to experiment a bit. If that works, I'll cut all my other ones down too. But with the capacitor, I always run negative side pointing down. That way there's no way I can accidentally confuse it. It's just a really easy way to look. What I'm going to do is bend the arms on this into the quad. So from here, I'll just sort of pop this up like so. And bend in the wires this way. And what I like to do is just use a knife, sort of right beside it, and then you can just push on the wires. Like so, try to keep it pretty even. I have these pointing in a little bit just because then when I put the wire on the outside, it'll be sitting just at the right point. Okay, when I'm cutting this, I like to cut a little bit inside of the cap. Sort of like so. And the reason why I do that is so that when the cap's actually on top, the little 3D printed piece, there's no actual exposed wire. The other thing you want to keep in mind when you're soldering this is you don't want to get any solder connecting the pins to the outer cap. If you do, your capacitor will sound like a rocket ship, but it won't last very long, so don't do that. Okay, so we have the capacitor all soldered up now, and as you can see, the little red cap just sort of slides on top. So what we're going to do now is add tape. I usually go one wrap of tape around this way and then one wrap of tape around the side. That way it's fully covered and won't accidentally pop off. So that is the capacitor all ready to go in. This side you don't need to worry about covering, this side doesn't actually, it's just part of the can, so it's okay. You can cover it if you want though. But that's basically the whole capacitor setup. So we'll get this fitted now. When you do this, you do have to loosen this a bit because this is a touch wider than 19mm, but because this is TPU, it will compress, so it will be okay. So you just want to loosen up your front standoff a little bit, and then loosen up camera one a little bit. You don't have to do the camera one usually after you've done it once, but just for the first time really. And I try to thread it and keep the negative one, the bottom one, at the bottom. A really good way to actually get this right is to use the right colored installation to start with, instead of doing what I do and use all of my motor wires. So yeah, probably actually just get the right cables, unless you want to be like me and just use black cables and get things wrong and turn things into sounding like rocket ships. So let's get this going. I'm just going to thread this through. Now, negative is the one I'm going to solder last, so I'm going to leave that out, and the positive I'm actually going to solder first because that's closer to the pad, the closest pad. So this one I'm actually going to tuck straight under the power wires for the motors. Okay, so this red one here, I'm going to thread straight under the motor wires, and then I'll do the black one after I actually finish soldering the positive. So for now, I'm just going to tuck this in here, that way they're separated, they can't get confused. Like I said before, just use the right insulation and then you won't have this issue, unless you're me and want to just have black wires and yeah, deal with these kind of issues. Okay, so I've already cut the positive wire to length, but what I do to get the negative wire right is when I bend this, I cut it so they're even. And the reason why I do that is because they'll actually end up with a bit more length than the black wire. But what that means is that when it's on the quad and it's pointing in the right direction, you'll have just the right wire lengths. One thing I forgot to mention, when you're soldering an XT60, it's really handy if you have the male connector side also, not attached to anything. The reason why you have this is so when you plug it in when you're soldering, the actual connector doesn't lose its shape. Sometimes, even though these are rated to take a lot of heat, when you're soldering, you're putting that much heat through these can actually move out of shape, and when they do that, they won't actually connect properly anymore. So having another connector in there just means that it'll hold its shape better and it'll give you a bit more time to play with. Okay, so here is the completed build. What we've done, we've soldered the XT60 on and the capacitors. Make sure when you do this you have a nice wet solder joint. You don't want it to be a dry solder joint and have the capacitor wires desolder and start splattering stuff everywhere and shorting things out and causing explosions. So make sure you've done that right. Other than that, I've made sure that my wires, as soon as these leave the pads, they start to pull off the flight controller. That's just trying to reduce the amount of vibrations going through the flight controller, try to limit things touching the gyro. Let's put the pod on. I'll show you how to do that now. Pretty much what you're going to do is slide the pod over the top, like so, and then there's two rear clips. You're going to line those up, sort of like that, and then you just sort of run your fingers over the top bit clips in, then over here, just clip in real hard, and then there you go, that's locked in now. And we are ready to race. Well, as soon as I set up the firmware, we're ready to race, but there you go, it's the final quad in my fleet, and that is the JS-1 Generation 1. I hope you enjoyed the video, guys.
Here we go. BMS Thomas, Bulldozer FPV, and Moto FPV. The ace is Min Chen Kim. It is time to chase the ace. If you beat him, you're closer to $10,000. Let's do it to it. Thumbs up. Arm your quads. Live on the tone in less than 5. Great start for our entire field. 4 wide as they go over the river on the backside. It is Min Chen Kim right above in front now. Min Chen Kim dropping in the second. Kang up the number 1 spot. And BMS Thomas running third. Moto now sliding up number 1 spot just in front of the gate. Moto FPV pushing it out of the trees. The rest of the field right behind him. 1 lap down and 4 more to go. Watch the blue LEDs as Moto FPV just bit it into a gate. There's some breathing room for the rest of the field. Everyone working on lap number 3. And Min Chen Kim just went on his lid. Story time, drama time, holy guy. Let's keep pushing on. Lap number 4, BMS Thomas and Bulldozer. 0.2 of a second apart. Now Min Chen Kim is back up, but there's no way that he's going to be able to make up these 8.5 seconds in the next 2 laps. What am I talking about? He can do those 10.8 second lap times. BMS Thomas, red LEDs about to come to our checker gate around that tower, low side, and Chase the Ace. Round 1 goes to BMS Thomas. Yes.
MCK 太紧张了，太紧张了。